7.1.
Hey, you gotta listen.
Solve linear systems by graphing. Okay, this might be one section where you end up wanting some graph paper. It just makes things a little easier, but if you don't have it, that's completely fine. I don't even think, I don't know. I thought at one point that I could like, oh, I can't add lines. Huh. That's exciting. Okay. I'm gonna get rid of them for the moment, and then I'll put them back when we need them. All right, so some definitions. You'll see me write this a lot, meaning definition, okay, just a shorthand for that. So the first one, a system of linear equations okay, sometimes it's also just called a linear system. It consists of two or more linear equations in the same variable. Okay, or actually it should be variables because it has multiple variables. So an example would be something like 2x plus 3y is equal to 5 and negative x plus 7y is equal to 2. Okay, that's a system of linear equations. The solution, okay, SOLN is another one you'll see that I write a lot for solution. Okay, so that's the shorthand for that. If you ever forget what their shorthands are for, you can always ask. Sometimes I'll do them and not think to tell y'all what they mean because I forget that like everybody doesn't know what they mean. So if there's ever something that you're like, I don't understand, just let me know. It's a solution of a system of linear equations. So it's just saying the answer to the linear equations, okay? It is an ordered pair. That satisfies each equation in the system. We'll get lots of different methods that we can solve them by using. In this particular section, we're doing it by graphing. There will be other methods that we'll use as well. Sometimes I may specify that you have to use a particular method. Other times I may just say solve the system and you can use whichever method is your favorite. Okay. Let's see. We'll just go ahead and keep doing definitions and then we'll go back and do examples in a little bit. All right, so there are different types of linear systems. So one is a consistent independent system. And that has, for the graphing part, it has lines are distinct. Okay, that's where we get the independent part from. And they intersect, which is the consistent part. And these have exactly one solution. Okay, we may have some at other points that have no solution, or have infinitely many solutions, but those come in a later section. Did I go up too far? We good? All right, so solving a linear system using the graph and check method. Graph both lines. Or I should say equations. On the same coordinate plane. Okay, so all of them on the same graph. Okay, both lines. Don't like graph them on two separate things. That won't help you. Sometimes it helps to write in slope intercept form. Okay, so the y equals mx plus b. It may be easier to rewrite the equations that you're given in that form just to make your life a little easier when you're graphing them. So then the next step is to estimate, okay, which is kind of just a guess. That's why I would recommend graph paper, just because of the fact that you have to find a particular point that intersects, and if you're even a little bit off, it'll throw your answer off. So estimate the coordinates of the point of intersection. And then finally, check the solution by plugging it back into the original equations. Okay, so this is the check part. Sometimes it's mandatory, sometimes it's not, okay? But the check part guarantees that your answer is right because you plug it back in and you can see right away if your answer is right. So as we go through problems, I'll show you how to know for sure that your answer is correct. Let everybody get that down before we start doing a few examples. And I will say, in terms of finding the answer, this might be one of the hardest sections in this chapter just because your graphs have to be so, like, spot on. So we may not spend a ton of time on this section, but if we don't spend a ton of time on it, I'm not going to put a ton of them, like, on your quizzes and tests and stuff like that. You'll probably have, like, one of these on a quiz or one of these on a test, just to show that you understand the general concept of what to do with it.
It is raining though.
Is it really?
Yeah.
Oh, I have carpool.
Can I check out the window because James bet me $1 if it's raining?
I don't care. I can tell that it's dark. I just have the windows
You owe me
closed
$1, it's not
because
raining.
I take it back.
Nope, too late. It's raining, you owe me $1. It's raining to be hard. You can't take it back like that, you owe me $1.
I did.
That's why you don't bet.
No.
It's not like negative.
But it's raining, so you owe me
You want to go to class, just be wet.
$1. The class could just be wet.
Yeah.
What?
I really hope it stops raining about 3:10 so that when I go out to carpool I don't get soaked.
Maybe make James do carpool since he lost.
I don't know if Mr. Law would be okay with me passing off carpool to a student, but
James can do it. Can James do carpool? No, he can't. He's gonna get hit by a car. I'd laugh. It's okay.
honestly, some of those people out there kind of freak me out. Like, I don't like the corner because I feel like I'm gonna get run over.
Oh, my mom freaks
There was
herself out.
people last year that like they go through the line and stop right at the beginning so they could let their kid off. Like,
Oh, I know. It's so
it's
annoying.
Because it backed up everything.
Just like pull all the way
Well, me and my
down.
mom were walking up, we saw like you like doing the thing, and like there was this car that just like went right in front of you and just turned back into the thing.
I know, I was like, hello? I was like, what are you doing?
My dad went to the wrong line like a few days ago, and I was like, Dad, just park so it doesn't look like he came into like went in the wrong line. So we just parked and he
My
drove
mom
me
just
out.
said she's gonna park super far away, so I have to walk, and then she regrets it when we have to walk back.
Yeah.
Exercise.
But
You wanna
wasn't
do it
she?
again? You wanna walk all the way to my car and back?
Wasn't
Go
your
ahead.
wasn't your mom a PE teacher, Ava?
Okay, but what?
Wasn't your mom a PE teacher?
My mom wasn't PE teacher.
And she can't
She is
walk.
right now.
And she
So what?
can't walk
Elementary.
to her.
Keep quiet, please. You're just in the
Well, your James, my mom told me to tell you that she misses you and Preston in computer.
Really?
Yeah. She said that
Why
it's
not me
added.
and Rylan? What was wrong?
Oh, I forgot, yo. I forgot you were in this class, Chris.
All right, so we have all these notes down so we can start going through examples. Awesome.
Where did you get your glowy
I
pencil?
still have it.
I have this.
This?
Especially got in
No, the
trouble with
glowing
it because he used this cord so
This
much.
one,
Yeah.
IKEA.
There's no way.
IKEA? Maggie, we're going to IKEA.
Yeah, I know.
All right, so the first problem say to tell whether the ordered pair.
We go right there.
Yes.
This is just the instructions. You don't have to write them down. I just am so that we can keep up with what we're doing. Is a solution of the linear system. All right, so normally I won't do odd ones, but this particular little section only has a couple problems, so I'll do one odd and one even one. So number
Have
3.
One on and one even, or just two problems. One on and one even.
Well, in that little like section before we move on to the next part of the actual graphing. So we're given the point -3, 1, okay? And our linear system that's given to us is x plus y is equal to -2, and x plus 5y is equal to 2. So with this, this is just showing you the checking step. So this is showing you step 3, okay, of that 3-step process of how to check your answer after you've gotten your ordered pair, okay? So just as a reminder, this is x, this is y. So we're going to plug that point into both equations separately.
Is this what we're doing?
Does that say 5?
This is part of it, yes.
Does that say 5?
Yes. So I'm going to take and plug -3 in for x. So -3 plus 1's going in for y is equal to -2. -3 plus 1 is -2, which is equal to -2.
No solution.
Wait, I mean.
What?
I mean, solution.
Now it's pouring.
You go put a check.
Yeah. James, go check out the window. Go check out.
No, it was pouring out there. It's spring pouring
Fantastic.
by pouring.
Well,
So
shut up.
Alright, well I need to also check, just because the point worked in one does not mean it's a solution of both, so I need to check it in the other one as well. So I'm going to put in -3 plus 5 times y is 1 is equal to 2. -3 plus 5 is 2, which is equal to 2. So this one is a solution.
Yay.
Okay? So you need to show your work like this. Show that the left side is equal to the right side
move out the window.
to show that it's a solution.
It's a large center.
A
Yeah,
light
let's do this.
simmer?
I can't really tell.
Is it a light simmer or is it boiling?
Okay, if by chance you plug it into the first equation and it is not true, you don't have to do the work for the second one.
So it's a light simmer.
Okay? So let's look at another example and see what happens here. So we're given the point 5, 2, and the problem is 2x minus 3y is equal to 4, and 2x plus 8y is equal to 11.
I'm assuming this doesn't work because the last one worked.
You never know. Sometimes the book likes to be a little tricky. Alright, so I'm going to do the top equation first. So 2 times x is 5 in this case, minus 3 times y is 2 is equal to 4. 2 times 5 is 10, minus 3 times 2 is 6. It's equal to 4. 4 equals 4. So that one works, but I've got to check the second one. So 2 times 5 plus 8 times 2 equals 11. Okay.
Incorrect.
10 plus
Plus.
16 equals 11. 26 does not equal 11.
I called it.
So it's not a solution.
I deserve trash in front of one and I called it before the problem was done. And James deserves 2 of mine. The top is tapped the other one. Can y'all stop playing PMZ? What's it
My
called?
mom does.
Oh, your mom.
Alright, I'm going to give you guys one to try here. I'm going to modify problem 6 a little bit. Okay. Problem 6. It's going to be just use the same instructions as what we have been doing. Okay, I'm just going to use the numbers that they've given us. So the ordered pair is going to be 0, -2, and your linear system, first one is x plus y is equal to -2. Second one is 7x minus 4y is equal to 8. So check and see if that ordered pair is a solution to the system.
I might guess. Okay, well then fix it. It's bothering me. It's a scribble that will lead it over my masterpiece that I drew. So I'm sorry.
this smiley face.
What tongue sticking out?
All right. What do we think? Is this a solution or not?
I got yes.
Yes.
I got this one.
Yes. Okay. So we put in 0 plus -2 is equal to -2. That means -2 is equal to -2. That one worked. And then for the other one, 7 times 0 minus 4 times -2 is equal to 8. -4 times -2 is positive 8. 8 equals 8. So it is a solution.
I don't get it.
Good.
All right, so open your books to page 431. We're gonna look at the next couple problems here, and there's graphs drawn for you. So, that's why I need you to have your books open.
Oh my god. That did not work. Yeah,
Page
split
what?
it.
431.
You're welcome to force me to nod.
All right, so I'll write the linear system out.
431.
But your book has it graphed for you.
Thank you.
Okay, in this case. So what it wants you to do is to use the graph to solve the linear system and then check your solution. All right, so we're looking for that point of intersection, okay, in problem 8. So what is the ordered pair that is the point of intersection there?
It is
1, 5?
1, 5.
Me 15.
No, I think it's 1, 4. It's 1, 4.
It's 1. Wait, 1. It's 1, 3.
1, 3.
Yes, it's 1, 1.
Okay, you're looking for where the two graphs cross.
1, 3. Okay. I can't count. I'm
It is
assuming
1.
it's 1, 3.
Okay, the one part is right.
So I counted wrong.
That's 3.
Is it 1,
1, 2, 3.
Yep,
Oh,
one
I
negative
meant- that's
3.
what I meant 1 negative 3.
1, 5.
Okay, so remember they're negative when you go down. Okay, so that's what it looks like the point is, but obviously, to be safe, it wants us to check it. So we're going to plug it back in. So we've got 1 minus -3 is equal to 4. So that's really 1 plus 3. And 4 is equal to 4. So we know that equation worked. We need to check the other one. So 4 times 1 plus -3 is equal to 1. So this is really 4 minus 3 equal to 1. So 1 equals 1. So that means that that is, in fact, the solution to the equation.
Thanks to Maggie for correcting my error.
Well, and that's part of why you check it, because then you would have realized
See,
that.
I knew it was negative. I just wasn't paying attention that it was negative, you know?
Yeah. But see, that's part of the checking thing. You would have realized that, hey, this number's like, if you had plugged in 1, 3, you would have been like, this isn't working. And you would have realized to fix it to make it negative.
I'm assuming we're going to have, in the homework problem, we're going to have to graph it ourselves and then
Some of them, yes. Like you'll have number 9 as a homework problem. So that one is graphed for you.
Yay.
But yes, we will get into the ones where you actually have to graph them.
I guess I did. My thing.
All right, let's look at number 10 as well. So this one, the linear system is x plus y equals 5 and negative 2x plus y equals negative 4.
I got this.
So what is that intersection point there?
It is
3, 3.
No, it's not.
3,
No.
3. It is
No, it's not.
1, 2, 3.
Are you? Is the one that's
No, it's what? It's 3-2.
A 3-2. Yeah.
Okay, 3-2.
Yeah. 3-2. Joey.
2-3.
Shut up,
It's-
James.
Okay, so then we're gonna check it. So plug in the 3 and the 2. So 3 plus 2 equals 5. 5 equals 5. Definitely works in that one. Need to try the second one. -2 times 3 plus 2 equals -4. -6 plus 2 equals -4. -4 equals -4. So that means that is the solution.
Let me refrain from doing 24 through 26. So that's too many fractions for my brain.
I wouldn't ever make you graph something with fractions in it.
What about
Thank
decimals?
you.
I should be careful how I word that because graphing parabolas sometimes has fractions.
Yeah, but like this is.
But it means something different then.
You have the same rule for decimals.
I would not make you graph 24 through 26.
Thank you.
I might make you check one of those,
Okay,
but that's different. And like technically 16 has a really weird answer. I wouldn't make you do 16.
Stop.
All right, what I'm going to do is I'm going to do one example where we graph it ourselves today, and then I'm going to give you a couple problems to work on that are like what we've already gone over. And then tomorrow we'll spend most of the time doing graphing examples and trying them. I'll work some, I'll have you guys try some, and then I'll actually assign some for homework, if you will. Okay, today's Wednesday, so there can't be homework. So, all right, so one of these, so we have to solve by graphing, and then it says to check, so we're going to do that. Okay, so I'm just going to start with number 12, and we're just going to work our way kind of through even ones tomorrow after, we do this one today, but it's already in y equals mx plus b for us, so that's nice. So we've got y equals -x plus 3, and y is equal to x plus 1. All right, I'm going to put the grid lines up here for me to have some graph paper to go off of. I just think it will be helpful. All right, so I'm going to draw my graph. All right, and make sure you're labeling stuff at least in one direction so that we know, okay? Just so it's clear, if you have something that's really, really big that's getting graphed, okay, you might count by 2s or something like that, and so that's why you need to have something labeled so that it's very clear what you're dealing with. All right, so for this one, okay, I'm going to graph the first line. I'll graph the first line in red, okay, and then I'll graph the second line in blue. All right, so for the top one, what is my y-intercept?
It is.
3, okay, so I'm going to go up to 3, and I'm going to put a point. Now, what is my slope?
1.
Down 1 over 1.
Okay, it's negative, so it's going to be down 1 over 1, down 1 over 1. Okay, and normally I will graph about 2 points and then I'll just draw the line. What I will say with these is you might want to be careful and actually plot them all and then connect them because of how important it is that your graphs be straight so that they line up so you'll be able to see the point of intersection. Don't forget with a negative slope, you can also go up 1 and back 1, okay? And hopefully I've got enough drawn that they're going to intersect somewhere and I'll be able to see it without a lot of problems. All right, so that's the top line. What's the y-intercept for the bottom one?
1.
1, so I'm just going to go up 1 and put a point, and what's my slope?
Up 1 over 1.
Okay, up 1 over 1. And I can already tell where it's going to happen in this particular one. Oh, that's not going to be.
Joey, she grabbed. She just grabbed.
All right.
You're a wizard, Harry.
So the intersecting point is right here. What is the ordered pair for that intersection?
I can't.
1, 1. No, wait. 1, 2.
Okay.
I really can't see.
I'm gonna take these grid lines away now because I think it'll make it easier to see. All right, so we said that this point is at 1, 2. Okay, we want to check it though and make sure that it's right. So I'm gonna take it and plug it back in. So now I've got, it looks a little different, but we do it the same way. Okay, so I've got 2 is equal to negative x is 1 plus 3. Negative 1 plus 3 is 2. So 2 is equal to 2. So we know it works in that one. So that looks promising. Checking the bottom one, we've got 2 is equal to 1 plus 1. 2 equals 2. So that means that that is in fact our solution to that one.
Close his eyes for 1 second. You said you're a wizard when she grabbed the line. You did not know how to draw a line.
She deleted it.
It's called a
With
freaking
the
tablet.
pin. No, with the writing part of the pin.
No, I didn't. I did that.
It's called the eraser button.
She
Erased
didn't
it.
even flip it though.
Okay, maybe more.
You don't have to.
I'm doing it right now.
You're doing what right now?
I'm switching between the eraser and the pen right now.
Oh. It's so magical, isn't it, Joey?
Joey
I
doesn't,
didn't see that up there.
Joey does not understand.
If Joey worked for Disney, he'd make a movie about how
I
fantastic.
make Joey do that because I know he knows it now. So
About
you're doing that
magical
dance.
graphite.
I'll make
All
you do
right,
that dance.
I'm listing these as homework, but they're obviously not homework for today, but you have a couple minutes, 15 minutes or so, that you can try them. So if you want to get a head start, after we're done with this section, it'll all be due the following day. Okay, I don't know for sure if we'll finish up the section tomorrow or not. But anyways, if we were to finish it tomorrow, it would be due Friday. So if you want to get a jump start on it,
Wait, so which problem
do
is
that
it?
now. I'm
No,
getting there.
I'm doing his homework right
5, 9, and
12. No, I don't want 12.
we just did 12.
13.
Y'all want to try 13?
James, I murdered you.
Let's go with you guys try 13. Okay, I've only obviously done one problem like 13, and so it's just kind of a see how you do with it. Okay, it's the same principle as 12. It's already in y equals mx plus b for you, and then tomorrow we'll pick up with 14 and work through some of the even ones as we go.